Let's start with AI, artificial intelligence. AI is the broad field of creating machines that can perform tasks that normally require human intelligence. Things like recognizing speech, making decisions, playing games, recommending videos, or even driving cars. Think of AI as a big umbrella. Anything that allows machines to behave smart falls under AI. But here's the important part. AI by itself doesn't actually learn. It needs an engine to improve, adapt, and get better over time. And that engine is called machine learning. Machine learning, or ML, is a subset of AI. If AI is the idea of making machines intelligent, machine learning is how machines actually learn. Instead of programming every single rule, like if this happens, then do that, we give the machine lots of examples and let it discover patterns on its own. Think about how humans learn. You didn't learn to recognize a cat because someone explained whiskers, ears, and tails to you in detail. You learned because you've seen many cats. Over time, your brain connected the patterns automatically. Machine learning works the same way. It learns from experience, not instructions. Machine learning works through 4 connected pieces: data, algorithms, models, and training. First, data. Data is the foundation. It's like real-life experience for the machine. Without data, the machine has nothing to learn from. And not just any data, high-quality data matters. If the data is messy, biased, or wrong, the machine will learn the wrong thing. Second, algorithms. Algorithms are the learning methods. They decide how the machine studies the data. Some algorithms are good at predictions, some are good at finding hidden patterns, and some learn by trial and error. Third, models. A model is what you get after learning. After the algorithm studies the data, it produces a model, basically a trained brain. This model can now take new input and give output, like predictions, classifications, or recommendations. And finally, training. Training is the learning process itself. The model makes a guess, checks how wrong it was, adjusts itself, and tries again. Step by step, mistake by mistake, it improves just like practice makes humans better. Once training is done, the model is ready to work in the real world. There are 4 main ways machines learn, and they're surprisingly similar to how humans learn. Supervised learning is learning with a teacher. The machine sees examples with correct answers, like photos labeled cat or dog. Over time, it learns how to classify new images correctly. This is also used for predicting things like house prices. Unsupervised learning is learning without guidance. No labels, no answers. The machine looks at the data and groups similar things together, like discovering customer types based on shopping behavior. Reinforcement learning is learning by trial and error. The machine takes actions, receives rewards or penalties, and slowly figures out what works best. This is how game AIs improve and robots learn to walk or navigate. Semi-supervised learning is a mix of both. The machine learns from a small amount of labeled data and a large amount of unlabeled data, combining guidance with exploration to improve accuracy. Some problems are too complex for simple machine learning, like recognizing faces, handwriting, or human speech. That's where neural networks come in. Neural networks are inspired by the human brain. They're made of layers of connected neurons, and each layer understands the data a little more deeply than the one before it. For example, when a neural network sees a cat image, the first layer notices edges. The next layer detects shapes. Another layer recognizes features like eyes or whiskers. And the final layer understands, yes, this is a cat. Each layer builds on the previous one, turning raw data into real understanding. When neural networks become very deep, meaning they have many layers, we call this deep learning. Deep learning is powerful because it can automatically learn extremely complex patterns without humans manually defining features. That's why it's used for image recognition, speech recognition, language translation, self-driving cars, and recommendation systems. And this same technology is what powers generative AI. Generative AI is the creative branch of deep learning. Instead of just recognizing or predicting, it can create. It learns patterns from massive amounts of data, text, images, music, and then generates new content that feels human-made. Tools that write text, generate images, compose music, or create videos all come from this idea. We'll cover generative AI deeply in a dedicated video. So let's quickly bring it all together. AI is the big umbrella of smart machines. Machine learning is how they learn. Data, algorithms, models, and training make learning possible. Neural networks and deep learning handle complex tasks. And generative AI is the creative powerhouse. Machine learning isn't magic. It's data, algorithms, and practice. If you want to go deeper, I'll make follow-up videos breaking down neural networks and deep learning with examples and visuals. Like, subscribe, and comment which part of AI you want me to break down next: deep learning, neural networks, or generative AI. Let me know and I'll make it happen.